Welcome to Science Sphere, where we unravel the mysteries of the cosmos. Today, we're diving into one of the most profound questions in all of science. Can we find a theory of everything? If you've ever wondered if there's a single explanation that ties together everything from the vastness of galaxies to the tiniest particles in existence, you're in for a fascinating journey. So here's the big question. What is the theory of everything, and why is it such a big deal? For over a century, physicists have worked with two incredibly successful but separate theories. One is general relativity, Einstein's masterpiece that explains how gravity shapes the universe. It's perfect for describing massive objects like stars, black holes, and the expansion of space itself. Then, we have quantum mechanics, the framework that explains the tiny weird world of particles like electrons and photons. It governs the laws of nature at the smallest scales. But here's the problem. These two great theories don't get along. They're like two sides of the same cosmic coin that refuse to meet. Why does this matter? Well, if you want to understand the whole universe, from the tiniest subatomic particles to the largest cosmic structures, you need a theory that can do both. Enter the hunt for the theory of everything. A single theory to explain all the forces of nature, gravity, electromagnetism, the weak and strong nuclear forces, in one elegant, universal equation. One of the most exciting candidates for the theory of everything is string theory. Now, this might sound like sci-fi, but it's real cutting-edge physics. String theory proposes that all particles are actually tiny vibrating strings of energy. Just as the notes of a violin string create music, these fundamental strings vibrate at different frequencies to produce the different particles in the universe. But there's a twist. String theory suggests that the universe has more dimensions than the four we know: height, width, depth, and time. According to this theory, there could be as many as 11 dimensions. Imagine that. Whole realms of reality beyond what we can see or even imagine. But as captivating as string theory sounds, it's incredibly hard to prove. We don't yet have the tools to detect these extra dimensions or the strings themselves. That's where loop quantum gravity comes in. It's another candidate for the theory of everything. And instead of imagining particles as strings, it suggests that space itself is made up of tiny loops, almost like the fabric of the cosmos is woven together. This theory takes us closer to understanding gravity at quantum scales, but it, too, remains unproven. Now you might be wondering, why should we care? Well, the stakes couldn't be higher. If we discover a theory of everything, it could unlock answers to the deepest questions of the universe. What happened at the Big Bang? What happens inside black holes? Is time travel possible? And could we one day harness the fundamental forces of the universe itself? This pursuit isn't just about answering abstract questions. It's about changing how we see ourselves in the grand scheme of things. The theory of everything could explain not only the physical laws, but also give us insight into why the universe exists the way it does. Imagine knowing the very code of reality itself. But here's the tricky part. Despite decades of research, no single theory of everything has been universally accepted. Some physicists think string theory is too abstract, while others believe loop quantum gravity isn't the full picture. The truth is, we're still on this quest, pushing the boundaries of science every day. So, what will it take to finally crack the code? Will it be new technology, like a supercharged particle collider capable of probing the smallest scales of the universe? Or perhaps a genius breakthrough that connects all the pieces together in a way no one has ever imagined? Only time will tell. But one thing's for sure. The search for the theory of everything is one of the most exciting, mind-bending adventures in all of science. As we continue exploring the deepest mysteries of the cosmos, make sure you're right here with us at Science Sphere. The answers may still be out there, but together, we'll chase them down, one discovery at a time. Stay curious, keep exploring, and don't forget to subscribe to stay up to date on the latest breakthroughs. Thanks for watching, and we'll see you next time on Science Sphere.